Okay, so, we've talked quite a bit about the big picture with AI, the concepts, all of that potential. But how does someone like an AI engineer actually build something? How do you get from these powerful models to, something real?
Right. And that's exactly the shift we're focusing on in this deep dive, moving from the theory, the ideas, into actual practical AI engineering.
Yeah, getting hands-on. And our maps for this is an article by Avi Chula on Daily Dose of Data Science. It's called 10 MCP AI Agents and ARG Projects for AI Engineers.
And what's great about this source is it's not just concepts. It lists out actual projects, points you towards open source code. It's like a snapshot of what people are building right now.
Okay, so our mission today, unpack these 10 projects. We want to pull out the interesting tech, the tools they're using, and like what problems are they actually trying to solve? Sort of a shortcut to the nuts and bolts.
Exactly. And these projects, they really do highlight some key trends. Things like agentic workflows, different flavors of RAG retrieval, augmented generation, and of course, using these powerful open source LLMs that are available now.
Before we jump into project number one, the article mentions its sponsor, Browserbase.
I guess it does.
Yeah.
And it notes that Browserbase is providing the web browsing tech that a lot of these AI agents need if they have to interact with the live internet. The article also lists a bunch of roles they're hiring for, which is interesting in itself. Things like sales engineer, account executive, various engineering roles, distributed systems, dashboard, DevOps, infrastructure, plus marketing and design roles too.
Yeah, it gives you a sense of the kind of ecosystem needed to support all this. Okay, all right, let's get into these projects. I'm excited to see the details.
Me too. It's a really interesting list, each one tackling something a bit different.
Okay, first up, MCP-powered Agentic RAG. What's MCP here?
So think of standard RAG. It usually looks stuff up in its own knowledge base, right? Like a
Yeah.
database.
Yeah.
But what if the answer just isn't in there?
Okay. So this agent doesn't just give up, it has a backup plan.
Exactly. That's the idea. It mixes an agentic workflow, meaning the AI can take actions with RG, and it uses MCP, which the article sort of frames as a controller or a brain, for the agent. So
Right.
the agent first tries the vector database. If it doesn't find what it needs, the MCP part lets it then go out and do a web search.
Okay, that makes a ton of sense. Your own data isn't always complete, right? So it intelligently decides, need to look online.
Precisely. It adds that layer of robustness, adaptability.
Yeah.
Really crucial if your local data might be stale or just incomplete.
Okay, project two sounds, well, ambitious.
Yeah.
A multi-agent book writer.
Oh, yeah. This one's really aiming high. The goal is an agentic system that can write a, 20,000 word book, basically,
Oh,
just
yeah.
from short title.
Yeah.
Maybe 3 to 5 words.
A whole book. How does that even work? I mean, writing involves outlining, research, drafting, lots of steps.
And that's the key, the multi-agent aspect. The fascinating challenge here isn't just the writing, it's the coordination. You have to break down that massive task. Maybe one agent does the outline, another does research for chapter 3, others draft sections, maybe one keeps track of characters.
Like an AI writing team.
Kind of.
Yeah.
The real trick is making sure they all work together cohesively towards that single goal, not just, spitting out random bits. It's a huge orchestration problem.
Wild. Okay, moving on from pure text. Project 3 is RAG over audio.
Right, so taking the RAG concept beyond just text documents, this project is about building a system where you can query audio files. Think podcasts, lectures, maybe meeting recordings.
So, like, instead of searching my notes, I could just ask questions about that long lecture I listened to. What did the speaker say about X?
Exactly that. You need, obviously, an audio processing step first. Transcribe the audio, then embed that text, maybe other audio features too, into your vector database. Then the RAG system works on that index. It really opens up how we interact with all this non-text information we have floating around. This project gives a kind of blueprint for it.
Yeah, I can see tons of uses for that. Okay, Project 4 seems a bit more foundational. Build a local MCP server.
Yeah, this goes back to that MCP concept from the first project. If you want to build these agentic apps, especially using this MCP framework, you kind of need to understand the plumbing, right? So this project is about setting up your own MCP server locally.
And why do that locally? What's the benefit?
Well, control, mainly. And understanding, you get direct insight into how that core agent controller actually works. The article apparently walks you through it, maybe uses a simple analogy, and shows interaction using tools like Cursor IDE. Stepping back, understanding the server piece is pretty key if you ever want to customize, deploy, or scale up any kind of agent system.
Gotcha. Okay, back to RGA for number 5, but with a specific model. RA powered by Llama 4.
Yep, Meta's Llama models are super popular in the open source world, and Llama 4 is the latest one the source mentions. This project just shows how to plug it into a RAG setup.
And what's special about Llama 4 for RAG? Anything specific?
The source points to its better multilingual and multimodal abilities. So for RAG, that could mean building systems that handle different languages better, or maybe even data sets that mix images and text. It pushes beyond just plain text RAG.
Right, multimodal seems to be a theme. Project 6 is another one. Multimodal RA powered by DeepSeek Janus.
Exactly, another crack at multimodal RAG. But this one highlights a different tool set. It seems focused on handling maybe more complex data, like documents with lots of images, and doing it locally.
Okay, so different tools for the job. What are they using here? Copali, Qdrant, DeepSeek Janus.
Yeah, those are the ones mentioned. Copali is apparently good at understanding and embedding those mixed text and image documents. That's key for getting the multimodal data in. Qdrant is the vector database, pretty standard. And then DeepSeek Janus is the multimodal LLM doing the actual processing and answering. It just shows, there's a whole ecosystem of tools you can mix and match depending on the specific challenge, like this complex multimodal stuff.
Interesting. Okay, Project 7 brings us back to chat, but with a twist. A mini chat GPT using DeepSeek R1 running locally.
Exactly, like building your own little ChatGPT interface, but it all runs on your own machine.
Why would you do that? Privacy. Control.
Both, yeah. Your data, your conversations, they stay local. The project uses DeepSeek R1 as the model, Llama, which makes running these big models locally much easier, and Chainlit for building the chat UI quickly. What's really cool here is how these open source tools are like democratizing this tech, making it possible for more people to run and tweak powerful conversational AI themselves.
Makes sense. All right, number 8 tackles a really important problem for RAG, accuracy. It's called Corrective RAG.
Yeah, this is a big one. RAG is great, but sometimes the stuff it retrieves, well, it might be kind of relevant, but maybe misleading or just low quality. And that can lead the LLM to generate wrong answers. Garbage in, garbage out, right?
So Corrective RAG tries to fix the retrieval before generating the answer, like a quality check.
That's the core idea, yeah. The article explains it adds a kind of self-assessment step. The system looks at the documents it pulled back and asks, is this actually good enough? Is it relevant? If the retrieved stuff seems weak, maybe it tries searching again, or it flags the uncertainty in its final answer. It's all about boosting the reliability and relevance of the output, a really critical technique.
Definitely sounds useful. Okay, Project 9 shifts gears a bit. Build your reasoning model, so not just finding info, but thinking about it.
It's exactly. RAG is mostly about retrieval. Reasoning is, processing information, applying logic, maybe following complex instructions, drawing conclusions. This project is about fine-tuning a model specifically to get better at that.
How's that different from just training a general chatbot?
It's about specialization. While big models can reason to some extent, this aims to really enhance it. It uses a tool called Unsloth, which apparently makes fine-tuning way faster and more memory efficient, and applies it to a base model like Llama 3.18b. The goal is to make it better at tasks needing logical steps or understanding complex relationships, not just spitting back facts. Moving towards better reasoning is like a huge step for more capable AI agents.
I see. And the final project, number 10, gets even more specific. Fine-tune DeepSeek R1.
Right, so this one zooms in on taking that DeepSeek R1 model we saw earlier and fine-tuning it yourself, privately running locally.
And why DeepSeek R1 specifically? Any reason given?
The article apparently describes it as a distilled llama variant. So maybe it has some llama goodness, but perhaps it's smaller or different in some way. But the key point is the fine-tuning itself. It lets you take a capable base model and really tailor it. Train it on your own private data, maybe for a very specific task unique to your work. It's about making a general tool hyper-specific for your needs, all under your control.
Wow, okay. That was quite the tour. We really covered a lot of ground there. From agents writing books and searching the web to systems understanding audio and images.
Yeah, and improving RAG's reliability, building local servers, specializing models for reasoning.
It really paints a picture of the diverse, practical stuff happening.
Absolutely. It shows how people are using these open source tools and clever combinations to actually build things and solve real problems. Very hands-on.
Definitely. So just to recap, we've explored these 10 practical AI engineering projects based only on that source article by Avi Chawla over at Daily Dose of Data Science.
And importantly, the article usually provides links, GitHub repos, walkthroughs for anyone listening who thinks, hey, that one sounded interesting and wants to, actually try building it or learn more.
That's really the main point, isn't it? These aren't just abstract ideas, they're like actual blueprints. Seeing this range, agents writing, audio understanding, self-correcting RAG,
Yeah.
it really gets you thinking.
Yeah, makes you consider, which of these might map on to problems you're facing, or what seemed way too hard before but might actually be doable now with these kinds of techniques becoming more accessible.
Right. Which kind of leaves us with a final question to chew on. When you see all these different practical builds handling weird data types, coordinating agents, correcting errors, specializing reasoning what application, maybe something that felt impossible before, now feels like it might be just within reach for you using these kinds of hands-on approaches.